Hi guys, I'm Anand Chaudhary, an upcoming sophomore at Monte Vista High School, and today I want to go over another key core concept in calculus called implicit differentiation. So why don't we get on into it? But before I get on into implicit differentiation, I want to go over what we've been doing in these past few weeks with explicit differentiation. Now, explicit differentiation is when we just take the derivative of a function which is explicitly written in terms of one variable, such as y is equal to some function of x. But not all functions are like that. Some functions can just be a relationship between x and y, such as some of these problems over here, x cubed plus y cubed is equal to 1, where they don't exactly have, it's not written explicitly. So an implicit differentiation has its own separate process. So why don't we get on into the steps? So we have like three main steps that you want to follow when you're doing implicit differentiation. The first one being is you're going to differentiate both sides with respect to x. Now with respect to x is usually written d dx, just in case you don't know. If you guys are used to writing the dash and don't write it like this, d dx is the better way to write it, d dx, derivative with respect to x, or if you're taking the derivative with respect to y, you can write d dy or whatever you're taking it in respect to. But in all my scenarios here, I'm going to have it in respect to x. So yeah, we have it in respect to x, and you're going to take the derivative of any x term normally, because you're taking it with respect to x. Step number 2, when you differentiate a y term, you're going to take the derivative of it normally, but at the end of it, you're going to multiply a dy dx. And that's pretty simple, just multiply dy dx, but it's something that a lot of people forget to do, and it can cause a mess up in the problem. And the last thing is you're going to solve for dy dx. Now, I know sometimes the steps don't usually make sense to some people, so why don't we just head on into some problems and hopefully you guys can get an understanding for how to actually do the problem. So how about we jump into problem number 1 over here. Problem number 1, where we have x cubed plus y cubed is equal to 1. Now according to our first step, we have to differentiate both sides with respect to x. So why don't we do that? D dx of this whole left side, x cubed plus y cubed is equal to, and remember whatever you do on one side you have to do the other side. So d dx of 1. Okay, now we're going to distribute the ddx to both terms inside here. So you're going to do ddx of x cubed plus ddx of y cubed. And we know the derivative of a constant such as 1 would equal to 0, so we can write 0 here. And since this is an x term, as it says, you're going to take the derivative of it normally. So this first step over here, when you're going to take the derivative of x cubed, you're going to get 3x squared plus, but now we've come across a y term, which is going to cause a bit of a difference between implicit and explicit differentiation. So as it says over here, you're going to take the derivative of it normally and multiply dy dx. So if we were to take the derivative of this using power rule, we know it would equal to 3y squared. But what we can't forget right now is we can't forget multiplying it by dy dx, and it's equal to 0. Now, last step, solve for dy dx. So in order to do that, we can subtract 3x squared on both sides. We'll get 3y squared dy dx is equal to negative 3x squared. Now the last thing we have to do is divide 3y squared by both sides, and we can just do this here. Dy dx is equal to minus 3x squared by 3y squared. The 3 and 3 cancel out. And dy dx is equal to negative x squared by y squared. Okay, so that was our first problem. Now, yeah, it's a pretty simple process, just a little bit more time consuming that explicit differentiation. So why don't we move on to our second problem? So, number 2. X squared plus xy minus y squared is equal to y. Okay, now simply again what we're going to do, we're going to take d dx on both sides. D dx of x squared plus xy minus y squared is equal to d dx of y. Now you're going to distribute d dx all the way on the inside. So d dx of x squared plus d dx of xy minus d dx of y squared. And if you want, we could just take the derivative of this right now. If you take the derivative of y normally, it's going to equal to 1 dy dx, so just dy dx over here. So now we can get into the rest of the problem. So if you take the derivative, it's an x term, so you take it normally, so it's going to be 2x using the power rule. Here we have to use a bit of product rule, x and y. So what we're going to do is plus, take the derivative of x multiplied by y, so you're going to get y, plus, and this is just product rule, I'm just doing it a little quicker, and you have to do the same thing in regards to y. So you're going to take the derivative of y, but we know it's a y term, so you're going to have to multiply dy dx. So it'll be 1 times x times dy dx. So it's going to be x dy dx. Now, if you guys don't understand what I did here, see, we were given x, y, and we wanted to take the derivative of it. So I took d dx of x times y plus d dx of y times x. And this is just simple product rule, right? You do this over here, you're going to get 1 times y. Y plus 1, because it's a y term, so you're taking the derivative of that. So 1 times x times dy dx. 1 plus x dy dx. So that's simply what I did over there. So I hope you guys understood that part. So plus x dy dx minus, this is a y term, so minus 2y dy, oh wait, what am I doing? Minus 2y dy dx, and it's equal to dy dx. Now we've fully taken the derivative of this, and all we have left to do is solve for dy dx. So now what we're going to do over here is we're going to try bringing all the dy dx's on one side and all the normal terms on the other. So if we bring this dy dx to the other side, it's going to be minus dy dx plus x dy dx. And remember that at this point we're just solving for dy dx. And then minus 2y dy dx, and it's equal to minus 2x minus y. Minus 2x minus y. So at this point you can take dy dx common. In fact, we could take dy dx out, and this will become minus 1 plus x minus 2y is equal to minus 2x minus y. Now if you were to simply divide this term on both sides, dy dx would equal to minus 2x minus y divided by x minus 2y minus 1. And that is your answer right over there. Now it's quite a few steps, as you've noticed, but at the end you will get the same answer as you would no matter what. So we've done with question 2 over here, and all we have left is the last problem, which I've tried to make a little challenging using a little bit more trigonometry. So number 3, we have 4 times cos x sine y. Number 3, I made it a little more challenging, having to do with a little bit more trigonometry. So why don't we just jump on into it? So we have 4 cos x sine y is equal to 1. Now, remember, you just have to follow the steps if you want to complete this. So we're going to take the derivative with respect to x on both sides. D dx of 4 cos x sine y is equal to d dx of 1. Now we could take the 4 out because it's a constant, and we could just take the product rule of this, but we're going to follow the steps. 4 times d dx of cos x sine y, and it's equal to 0 because the derivative of a constant is 0. So what are we going to do now? We're going to take the product rule of this. So 4 times on the outside of this, and you're going to take the derivative of cos x first. So d dx of cos x times sine y. Okay, and then you're going to add it to d dx of sine y, the d dx of sine y times cos x. And it's all going to equal to 0. So if we completely simplify this out, this would be negative sine x, just taking the derivative. So negative sine x sine y plus, this is the y term, so if you take the derivative, you're going to have to multiply dy dx. So derivative of sine would be cos y times cos x times dy dx. And it's equal to 0. So if we divide 4 by both sides, you're still going to end up with a 0 on that side, because that's 0, 0 divided by anything 0. So we're going to have negative sine x sine y plus cos y cos x dy dx is equal to 0. Now you're going to add this to both sides. So you're going to end up with cos y cos x dy dx is equal to sine x. Yeah, sine x sine y. And then you're going to divide this term on both sides. So dy dx is equal to sine x sine y by cos x cos y. So that's implicit differentiation for you. I hope you guys enjoyed the video. Thank you guys for watching. If you guys haven't already, subscribe and leave any comments on any feedback you guys have for my videos. Thank you and have a great day.